Hi, this is Miss Michael, and today I'm going to go over punctuated equilibrium and gradualism. These concepts, at least punctuated equilibrium, involves a few of those evolutionary mechanisms that we have talked about in this unit. So, if you want to pause the video, take out your notebook, and write some notes down, I encourage you to do so. So.
This video will cover punctuated equilibrium versus gradualism. What is punctuated equilibrium? The easy definition is the rapid change noticed in the fossil record.
So I'm going to go ahead and pause this because punctuated equilibrium is a process. It shows a gradual change, then a sudden change or rapid change that we see in the fossil record, and then um, it shows just a very sudden appearance of species. And organisms are going to adapt to their environment. As we know, on our planet, we have weather patterns, we have seasons, we have things that the Earth does and that exhibit slow change. But we also have instances of rapid change. Some examples of rapid change would be earthquakes or volcanic eruptions, where suddenly islands are formed. We have natural disasters that have an effect on the organisms that are living on our planet. So, the idea that there has been gradual change over time without any sudden change, that idea is called gradualism. But punctuated equilibrium uh, takes in takes in the fact that we don't have some transitional fossils for some evolutionary change, but also we know that organisms adapt to the earth, and the earth has experienced sudden change just as organisms have.
In the video, we'll discuss how this occurs. The first step is finding a species in stasis. Stasis means the population is stable in finding resources and being able to reproduce. The species we're going to look at is a species of snails.
Okay, so again, stasis. This is a large population. It has ample opportunities to find food, shelter. It can reproduce. The environment is not extreme, and the example they're giving us in this short clip is snails.
The next step of punctuated equilibrium is population isolation. This is where part of the population becomes isolated or separated from the rest. In our example, a small group of snails become isolated in a tide pool.
Okay, so isolation. They're reproductively isolated. And like she said, an example, you have a population of snails where it breaks off and a small population becomes isolated. It causes genetic drift to happen at a much higher or lower rate. You have allele frequencies that are subject to change drastically because the population is small.
A group of snails become isolated in a tide pool. This newly isolated population will now be found in a new habitat. This new habitat will select the best traits for those organisms to be able to survive and reproduce.
Okay, so write that down. The isolated population, it's small, therefore it's going to experience a rapid change or rapid evolution. Again, genetic drift occurs in smaller populations. That larger population remains in a state of stasis where it's going to have some stability with food and shelter and reproductive capabilities. But again, this population that they're discussing, it is reproductively isolated from the larger population. Therefore, it will exhibit more rapid change or a larger shift in terms of genetic drift.
The new isolated population is so small, there will not be any evidence of it left in the fossil record. The population must increase and be found throughout the world in order for the progression to be shown. Now the two habitats will join together. In our example, you will see the tides rise, creating an area for the two snail populations to mix. Now, one will outcompete the other. You will now notice both species of snails living in the same habitat. The snails with the larger shells will need more resources to live and reproduce, outcompeting the smaller snails, causing them to go extinct. Now the larger shelled snails have reached stasis. They are living, growing, and reproducing at a steady rate. In the fossil record, you will now see a new species of snails visible. Punctuated equilibrium is the explanation on why we see such changes in the fossil record when dealing with fossils.
So let's look at the graphic they're presenting here. The graphic here on the left is showing that gradual change that we think of when we think about evolution. It has the transitional fossil record that we discussed when we looked at evidence of evolution. But here there aren't any transitional fossils. You have this population of snails that experience stasis. You have that sudden isolation that has caused a rapid change in a more isolated population of those snails. And then you have a sudden change in the way the snails are looking. And here it's showing that they went from this type of snail to this type of snail. And it is a rapid, punctuated change in the whole equilibrium of evolution that occurs with the population.
In reality, they change slowly over time, but we only see what was saved as a fossil in the record. Gradualism doesn't have an isolated population, but rather the changes in the fossils are recorded in the layers of rocks. Many times, different species from the same ancestor live together and are found in the same layers of rock, where one will outcompete the other, causing it to become extinct.
So, in this example, gradualism, we have transitional fossils. When we looked at tetrapods versus fish in our previous unit, we saw some examples of fossils that were more of a transition from an ancestral fish to a more current ancestor, excuse me, a more current predecessor. If you look here at the lineage here, there is a gradual change here, there is gradual evolution, and you have those series of transitional fossils. So when you have transitional fossils, that idea of gradualism makes more sense.
This is very evident in the progression of land animals to water animals. They lived together and outcompeted each other for resources. These populations were large and globally widespread. Both punctuated equilibrium and gradualism are explanations of evolution demonstrated in the fossil record. Thanks for watching.
Okay, so here again is another graphic where you have that rapid evolution, that rapid change that represents punctuated equilibrium, and then your transitional forms or your transitional fossils, those are evidence of gradualism.